Okay, cool. So I just started recording. Um, and today we're going to be going over authorization and authentication, how to implement it in a web app or just really any app in general. And we're going to be trying to understand a few couple of things that are just super, super important. So first, we want to understand user authorization and authentication. What is the difference? What does it mean? We're going to want to understand cookies, local storage, and JWT tokens, essentially the tools that any modern application uses for authorization and authentication. And we're going to be going into the different nuances of those. We're going to be learning about security exploits and the most popular security exploits, and specifically mistakes that everyday developers will make and that even large companies will make sometimes, and how we can combat them using the different settings in our different tools. We're going to understand password hashing and salting, how to build a login and sign up page. And then lastly, we're going to be utilizing in this specific technology stack, AWS DynamoDB, Lambda functions written in Python, and how we can utilize all this and how it all ties together in a very practical implementation of it all. So first things first, let's go ahead and understand what the difference is between authentication and authorization and what it actually is. So all authentication is it is the login and sign up part of an application. It's taking a username or some unique user ID, and it's taking the password, and it is authenticating whether or not you are that user, right? And then authorization is determining what resources and what actions a specific user that has been authenticated can take. So they're two sides of the same token, and they're really important to understand like how they fit in with each other. So now that we know that, let's talk about the different technologies that we're going to use. So let's talk about cookies, local storage, and session storage. So all of these different things are ways to store data for your application, right? And they differ in the way that they're stored, so like the location that they're stored and when they're communicated and transferred between clients and servers. So I'm assuming that everyone watching this understands what a client-server model is. You have the client or the front end communicating with the server and the back end. And yeah, let's start with local storage and session storage. So local storage and session storage are both stored on the computer. You write a line of JavaScript in your React app or whatever other JavaScript front end you're using, and you say, hey, I want to store this string in local storage or session storage. And it can only be read on the client side. So that means that if you want to read what's in local storage or session storage in your React app, somewhere in the front end, you have to say, hey, let's read this thing from local storage. An example of this would be, if you want to cache a user's image, you could write the image to local storage, and then later when you want to use it, you would check local storage in the JavaScript. Something to know is that you can access this only through the JavaScript on your front end, right? And that's where the big difference is between this and a cookie. So a cookie is also stored on a user's local computer, but in every single request that a client makes to the server. So every single time a client communicates with a server, that cookie is sent back and forth. So literally, it's just in every request, a cookie is sent back and forth. And then for every response that a server makes to a client, the cookie is sent back. Local storage and session storage, this isn't done. This is not done with those things. You would have to manually send a local storage attribute up to the server, and then you'd have to manually send a local storage attribute back to the server. And yeah, that's pretty much it. Cookies have been around for way longer, and local storage and session storage has just come about. Do you guys understand what the HTTP protocol is? Like how clients and servers communicate with each other, how the web communicates with each other? Sort of. Yes, no, okay. I'll just explain it anyways then. Cool, so for every single request that happens between a client and a server, there's data that is transmitted, and it's transmitted with essentially just like a text file. And that text file will have what type of request it is, who the host is, what type of user, agent, or client was making the request, a whole bunch of different things. And it will also send up a cookie, right? If there are cookies stored on that side. So that's really important. Just remember that. And the way that the client and server work together in terms of authentication and authorization can be shown right here in this image that I have. So the first thing you're going to want to do is you don't want to save it on local storage. Saving it as a cookie is better, and I'll explain why later. But let's say we were to save a user's information on the client device, right? So a user would log in with a username and a password, and we would send that over to the server, right? The server would verify whether that username and password is correct. And if it is correct, the server would return a token that says, hey, this client computer that is currently being used to make requests to the server has been verified because it had the correct username and the correct password. So it is verified to execute commands based on that user. And it would all be stored in this token that's stored on the client. And then anytime a client makes a request to the server, it sends up that token that's stored on the client device. And then the server can evaluate that token and see whether or not that token is valid, whether it's expired or not, and whether the user that token has authorized has access to whatever resource it's trying to access. And then, yeah, that's pretty much it. And then afterwards, the server will send the response back to the client, and it can be an error or it can be a success. Do you guys have any questions up until now that you want me to answer? No? Cool. So there are actually a lot of issues with this process though. So let's just go ahead and understand the security exploits, right? So there are two main security exploits. One is cross-site scripting and another is cross-site request forgery. So let's go ahead and start off with CSRF, or cross-site request forgery. So a lot of cookies are used to store a user's session information, right? And every single time a website makes a request to a server, that cookie is sent up for authorization. So CSRF is specifically an exploit based on cookies. And what'll happen is you will go to a different website. So let's use the example of google.com. So when you're on google.com, you have a cookie that's storing your user information, right? And there are a whole bunch of different actions that you can do with your user token, right? You can create a new Google Doc, you can send an email, you can access your private Google Photos. Let's say that there is a website that is trying to steal your Google information and is trying to perform actions using your Google account. What they would do is they would probably create some sort of website called maybe g00gle.com, right? And you would maybe accidentally type that in, or you would click on the site. And then on the site, you would have different buttons, and they would try to make it look like you're on the Google site. And what would happen is when you press a button, that website, g00gle.com, would make a request to Google servers. And because 00 Google is using the same browser that you use for regular Google, and you're making a request to google.com servers, it would send up the cookie to Google servers, and you could make the request anything you wanted, right? And then you could access information that is not yours to have. And you could send it back to this malicious website. And so the way that you get around that is you restrict a cookie. And you restrict a cookie by saying, hey, cookies can only be sent from the website that they were issued to. So if google.com is issuing a cookie, then google.com wants to make sure and say, hey, this cookie should only be sent up by google.com, not any other website. And it's actually a mistake that a lot of people make. It's a very common error. And so that's just something that you need to keep in mind. And then another big one that's actually even more common than cross-site request forgery is cross-site scripting. So all cross-site scripting is it is running malicious code on your front end. And you're like, oh, shoot, well, how is malicious code going to be written on my front end? Well, whenever you're creating a website and you're adding a script in HTML, or you're adding a library or a package or whatever else in your React.js application, those are all external libraries, right? Whenever you're using jQuery, whenever you're using React, whenever you're using all the bajillion JavaScript libraries that are being installed before you create a project, those are all third-party libraries. You have no control over the code that is in those libraries. And whenever you're retrieving stuff, like for example, for fonts, for like special effects, for like particles, whatever, you literally have no control over that code. And so if someone were to hijack that code and they were to say, instead of creating pretty particles on your website, they were to access your local storage or your session storage, they could steal a user's authentication information and then use it with the server to gain access to resources or do certain actions that they should not be able to do. Essentially, cross-site scripting is running code on your front end that you never meant to be run. And this happens whenever third-party libraries that you're using are being hijacked. And so you want to obviously use third-party libraries because there's no way you're going to code this stuff from scratch. But the way that you stay safe is that you make sure that you cannot access the user's sensitive data from your front-end JavaScript. And how do you do that? Well, you don't use local storage and session storage because, like I said earlier, local storage and session storage can be accessed using your front-end JavaScript. And you usually just want to use local storage and session storage for unimportant information that is relevant to the application but is not secure in any way, means, shape, or form. So what you want to do is you want to store user information on the client using a special type of cookie. So you want that cookie to be restricted to only being communicated with the same site that it was issued. And you want that cookie to be HTTP only, so it can only be communicated over an HTTPS connection. And then you also want to make sure that that cookie is, let's see, what is it called? Same site. Yeah, so you want it to be HTTP only, which means that it actually can't be accessed from the JavaScript, and that the only person that can read that cookie is the server that it was meant to be sent to. Does that make sense? If it doesn't, you can ask questions. It's definitely a more complicated level of understanding. It's a more complicated concept. And of course, this is a whole bunch of really good reading for this stuff. I would highly recommend looking at these different articles if you don't fully grasp what I'm saying today. So we've understood what authorization and authentication are. We understand the difference between cookies and local storage and why we should be using cookies instead of local storage so we don't fall victim to a cross-site scripting attack. And we want to make sure that our cookies are same site so we don't fall victim to a CSRF attack. So now let's talk about JWT tokens. JWT tokens are super simple. They're tokens that are designed for user authentication and authorization. So what a JWT token is it's essentially just a dictionary of three main attributes. One, it's the expiry time. Two is the user ID that it is authenticating for. And then three is any other extraneous information that you want to add. You can actually add as much information as you want into a JWT token, but the only things that really matter are the user ID, the unique user ID that it's authorizing for, and when it expires. And so the technique that we're going to be using for authorization and authentication is storing a JWT token as a cookie, and then using that cookie to communicate back and forth between the client and between the server. And if you don't trust me on this being the absolutely safest way, you can go ahead and do your own research. I put some links here for some resources, but I've done a lot of research and I can say that this is the best way to do it. So you should just trust me. Cool. And what I was talking about earlier with the entire cookie fields, they're right here. So there are a whole bunch of different cookie fields, like when a cookie expires and should be deleted from your browser, the domain that a cookie is meant for, the path, and the path is, with the different slashes after a domain, it's when should the cookie be sent back to the server. If you have the path set to like /user, then the only time that the cookie is going to be sent to the server is when you're at domain.com/user. So you usually just want to set the path to just a straight slash. You have secure, which, actually secure. Secure is the attribute that you want to use to make sure that it can only be accessed by the server and not your front-end JavaScript, not HTTP only. Sorry for the misnomer there. You want to have your cookies to be secure and HTTP only anyways. And then same site is ensuring that the cookie can only be sent by the same site that it was issued to. And you have strict, lax, and none. Josh, turn your video back on, please. Yeah. And we have the set cookie field, which can be returned by a server. And that's going to be really important because that's what sets the cookie. You don't set the cookie using JavaScript. You don't set the cookie on the front end. You set the cookie on the back end, and then when it returns the response to the client or the front end, then that cookie is sent and it's stored onto the computer. Cool. So now let's go ahead and look at some code. And I can go ahead and do that right here. So here it is. Here is my folder for all the different stuff that we're going to need. And yeah, so we have this authentication and authorization tutorial. And inside we have the backend, which is going to be the most important part of understanding what's going on in authorization and authentication. So there are a whole bunch of different files here, but the files with the code that we need to look at are authentication, actually, maybe this is authentication, user auth, and then the backend action example. And let's just go ahead and start from the authentication standpoint or the authorization standpoint. So if we open up user authorization, then we have a whole bunch of different code that I've written out to make it easy for you guys. Essentially, what this file does is it has some different wrappers to create cookies and to send those cookies back as responses to the client so that the client can set them, and store them on the browser locally. And then we also have functions that are issuing JWT tokens for specific user IDs. And we also have functions that are validating whether or not a JWT token is valid and whether it can be used by a user. And then that's actually, yeah, that's pretty much it. I'm not going to explain every single function that's going on here, but you should take the time to read through these functions for yourself. It's only 130 lines, so it's really not that much. But I think one step that I sort of forgot before delving deeper into this is talking about password hashing and salting and sort of like that entire thing, because that's super important before we go into this. So,
hey, Jonathan, I want to interrupt you for a second.
Go for it.
Is that file or is that folder in Notion?
No, I haven't uploaded it yet.
Okay, cool.
Yeah, but I'll walk through it. It'll be chill.
No worries, thanks.
Cool. So we have this understanding of authorization. We understand that the user inputs a password and a username. It gets sent up to the server. The server determines whether or not this password and username are correct. And if it is, it returns a JWT token as a cookie. And it returns inside of its response header a set cookie header. And the browser will read the set cookie header and interpret it, and it will then store that cookie onto its, local storage. It's not local storage, but it will store it locally. And for every single subsequent piece of communication that the client has with the server, it sends up that cookie to the server. The server will read the cookie, and within the cookie will be the JWT token. It will validate whether the JWT token is valid or not, and it will see whether that specific request is authorized for the user stored within the JWT token, and then that's the entire process. Makes sense? Does it make sense? I hope so. So what happens when a user sends up their password and their username? Let's look at this authentication file. So before we look at the code, let's just understand conceptually what happens. The user sends up their password and their username. So if a user is signing up for the very first time, then we never, ever, ever want to store a user's password in plain text, because that's super bad. Really, really bad. Never store a user's password in plain text, because if your database ever gets hacked, then all of your passwords are going to be sent out, and you've heard of all the different big hacks. This is really, really bad. We don't want this to happen. So a way that we can get around that is we can use a technique called hashing and salting. Salting, they go hand in hand together. So what hashing does is it takes a string, and it can be an alphanumeric string, so AKA your password. It hashes it, and what hashing means is it turns it into a completely different string that is unrecognizable to the string that was input. And with this hash, it is next to impossible to turn that hash into the original string that was input into the hashing function, unless you have the salt as well as the secret token that is used. So there is a password, you add a salt to it, and a salt is just an extra part of the string that is added to it to make it super hard for people to just get the original password. So for example, if my password is Apple, then I will add a random salt that I generate, like YRTZD, so that even if the hacker was able to reverse the hash into the original string, they don't even know the original password because there's that added salt to it, right? And sometimes what people will do to try to hack through and guess someone's password is that they'll use a whole bunch of different common passwords and they'll send it into the hashing function. But that won't work because they don't know that there's a secret salt added to the password that will make sure that they never, ever, ever are able to guess the password, right? So big brain moves. So the password has a salt added to it. It goes through a hashing algorithm, and what is output is a hashed password and plus, the salt, and then the salt. So if you're signing up a user, you take in all of their information that they have, their name, their attributes such as their location, whatever you're storing for your application. And then you want to store their password hash, not their actual password. And that's all good and dandy, but what do you do when a user tries to log in? How do you verify that their password is correct? Well, when a user is logging in, you get their username, and in the database, you're retrieving their password hash. And then you take the password input that they gave for login, you add the salt, you run it through the same hashing algorithm, and then you compare the outputs of the hashing algorithm. You compare and see whether the output of the hashing algorithm matches the password hash that you stored in the database. And if it does match, then you return success, true, and you return a user authentication token back to the client through a cookie, and then it's all fine and dandy, right? So let's go ahead and look at the code that I have here in the authentication.py file. So starting from the top, I have some different things that I'm importing. You want to make sure that these libraries are input yourself. And most importantly is this passlib library. This is the most well-known password hashing library for Python. And I would highly, highly recommend using this because it's tried and tested method. And you don't want to just rewrite the hashing algorithm yourself because that can be pretty unsafe. So the first thing that I'm doing is I'm establishing a connection to DynamoDB, which is the database that I've used for this authorization sign-up flow. And I have a function right here called error. All it does is it generates an error message, an error HTTP response that I can return with a Lambda function. So let's start with sign up. The sign up function takes in an event and a context variable. These are just different variables that are input from an Amazon Lambda function. And an event holds a whole bunch of different information pertaining to the function's call, but the body is what contains all the data that is sent up by the client. So the first thing that we're going to want to do when a user is trying to sign up is we're going to want to check to see if the user already exists. Because if the user already exists, then you can't sign up. So I'm checking the database here for the unique ID that was given to me. And if it exists, then I'm going to say the user already exists. If it doesn't exist, then I'm going to want to make sure that whatever unique identification method that they're using, it could be email, phone number, username, I want to make sure that that is valid. And for a lot of larger companies, they will use a text message notification or two-factor authentication to make sure that this is valid. And you can implement that. It just will take a little bit of extra work. Right now, I just have a very simple function that checks to make sure that using regex that it is in the correct format. And if you were to create, an application for just a university, maybe you would want to check to see whether they have a university-specific email. Cool. So we check to see whether it's a valid email. We check to see whether the user already exists. And then we take the password that was given to us by the client and we hash that. And this library is super cool because it adds in a custom salt there that was randomly generated, and you just hash it. Then I create a user object with the name, the unique identification with their email. And you can add obviously any other attribute you want here in this signup method. And then I have their password hash. And on this line, I am storing user item into the database. Right here, I'm going to hide the important information. So I would want to hide the password hash because you don't want to return the password hash back to the user. That's just really bad practice. And then I have this HTTP response that I'm returning. Notice that, I have the status code 200, and here I have some HTTP headers that are going to be really crucial if you're building a web application. I have access control allow origin. So I'm saying, hey, this response is only valid if the domain that is receiving the response is this specific domain. With credentials, all credentials is it's saying that I can pass up a cookie. And then right here, this is major. This is really, really big. It's the set cookie header. This header that is being returned from the backend, that is being returned from the server, is telling the client to set a cookie on the front end so that for every single subsequent request that a client makes to a server, it will send back up this cookie. And I'm using the user auth file that I will talk you guys through later to issue the cookie and the JWT token using the user's specific unique ID. This is important because you want to make sure that the authorization token, in this case a JWT token, contains the user's unique ID that it is authorizing for. Cool? Make sense? Awesome. That's sign up. So you can imagine now on the front end now knows that the user has been authenticated. It has the cookie. And so now it can interact with the entire other web application. So it can access whatever resources that this user has access to, which is cool. Yeah, and then when a user logs out, you clear the cookie from storage, and from there, it's done. Pretty much it. Cool, so if they're logging in from a different account, first you're going to want to, so once again, this is what the server is receiving from the client. You want to check that they have the unique identifier, which is email here, the password. You want to check whether the user exists, because if the user doesn't exist, then obviously you can't log in. And that's what I do right here. And then I verify the password with the salt and the hash. I have the user password input, and then I use the library to verify that these two things are correct. And it returns this Boolean password correct. Then I'm going to hide any information that I don't want to send back. If the password is correct, then I do that same exact thing where I create a JWT token, I make it a cookie, and I set the set cookie header, and I return that back to the client so it can store the authorization token on the client. And then if it's not correct, then I'm going to say, yo, something was not correct. That's all I have for authentication for the server backend part. Do you guys have any questions over this before I move on to authorization? Nope. Cool. Now let's look at the authorization file. And we can go ahead and walk a little bit through this, but I think the easiest way that we can do this is let's just trace the stack of a function call. So let's trace what happens whenever we are issuing cookie tokens, right? Because that's pretty much all that matters. So whenever we have validated that a username and password is correct, we want to issue the token, right? And so that's what's happening right here. So let's go ahead and look into user auth and look at issue cookie token. So if you see right here, issue cookie tokens takes in a unique user ID, and then it issues an access token and it issues a refresh token. Are you guys familiar with access tokens and refresh tokens, or do you want me to quickly go over that?
You can go over it.
Cool. So an access token and a refresh token is a technique used to make this process even more secure. So an access token will give a user access to a certain resource for a short period of time, usually anywhere between 5 minutes to an hour. And you want to make sure that whatever token someone can actually use for access, you want to make sure that that token expires fairly quickly, because if it doesn't expire fairly quickly, then it gives a hacker more time to take control of that access token and to hack it, to obtain access to it, and then use it to access resources and other things that it shouldn't have. So we use a two-token approach, or I've implemented a two-token approach with an access token and a refresh token. The access token expires fairly quickly, and it gives instant access to something. And on the client, the access token and refresh token are both stored. The refresh token is used to gain a new access token. Does that make sense, or do you want me to explain it a little bit?
So, for example, like my UT, right?
Mm-hmm.
That has a set expiration time for the access token, and then I guess the refresh token doesn't renew it. But like, for example, Google.com or Facebook.com, they let you log in for however long you want to log in for.
Right. So the access token and refresh token are just an extra layer of security. They're really not needed. All you need is just a JWT token, but I just made this super, super safe. I read this security article on the literal absolute safest way to create an authorization authentication system, and they recommend this. So the access token is temporary, it gives temporary access. And a refresh token is used to get a new access token. Once the access token and the refresh token are expired, then the user has to log in a new time and get a new set of access tokens and refresh tokens. Does that make sense? A little bit better?
Yeah.
Cool. So the first thing that I do whenever I'm issuing cookie tokens is I create an access token and a refresh token. Let's go ahead and look at those functions, which are right here. So a couple things to notice about this. One, there are multiple layers of encryption. So first of all, the JWT token is encoded, and it's encoded using a special token secret, which you can set up here. For obvious reasons, I didn't show the token secret that I've used in the past because I don't want you to hack me. But even if someone were to take a JWT token, it's freaking useless to anyone else because they don't have the token secret, right? So here in this JWT token, I'm encoding this unique user ID. I'm encoding the time that it was issued, and then I'm encoding the expiration date. And as you can see, for the access token, I'm saying that it should be allowed to be used for 60 minutes, and the refresh token should be valid for 7 days. This means that after 7 days, the user will have to re-log in. And you can make this any extent of time as you want, but I just made it a week just to be safe in case something is stolen.
Could you also make it so like if the user refreshes the page or like is active on it again, it issues a new refresh token and instead of like a time based?
Can you say that again?
So like, for example, if I'm on my UT, right, and sometimes it logs you out if you haven't been active for like an hour or so, but if you are like constantly active on it, it refreshes and lets you stay logged in. Could you also issue refresh tokens based on that, based on activity?
You could. You just have to change up the code a little bit, right? Yeah. Cool. So we've created these access tokens and refresh tokens, which are essentially just objects. They're just dictionaries that have been encoded. And then I create a token object, right? So just a tokens dictionary with an access token and a refresh token. And then I'm going to stringify this object, and then I'm going to make it a cookie, right? So I don't know how much you guys know about cookies, but you should look into it since you're going to be using them. I would recommend looking at developer.mozilla.org. super useful. Let's see. This is super useful. It can give you an overview of what a cookie, oh, that's not it. This one's it. Yeah, this is good. So this will give you a really good overview of cookies, the different attributes that they have, and how to edit them. I've, because I'm so incredibly nice, I've created a function for you guys already that creates a cookie string given certain parameters. So a cookie can be accessed using a key value store. You have a key, and then you have a value. So right here in issue cookie tokens, I'm saying the key right here is tokens, and the value will be the string, the stringified version of this object, which is storing access tokens and refresh tokens. And then these are all the important attributes that a cookie can have, and I've created them here in the function. So as you can see, usually I have let's see, same site. Okay, hold on. Let me check a couple of things. Let me check my Spotify buddy code really quickly to make sure that this is set up in the same way. And then I'll get back to you really quickly. That's not good. I need to edit this part out because that was some private information. Cool. Yeah, let's go ahead and go back here. Yeah, this function is fine. It's the same exact thing that I'm using. Like I said, you want to make sure you have HTTP only. Make sure that cookie can only be sent over a HTTPS connection. And then this same site. So let's go ahead and we can just look at what same site means. So right. So same site is going to be important. You should have same site set to strict. But it doesn't really matter because, okay, so you don't have to set it here because if your cookie is secure, so right here, if you set your cookie as secure, then it will automatically make it so it is same site strict, if that makes sense. Like that's why I don't have it set here in the code to make it same site strict, because if cookie is secure, it can only be accessed by the server, and client cannot read its value. Right? Do you understand why it's important that a client cannot read a cookie value if you're storing important information? That makes it so even if hackers hack your website on the front end, they can't access that important information. And so only the server, which your server is pretty much never going to be hacked. Well, hopefully. Your server is pretty much never going to be hacked, especially if it's hosted with AWS. So it's going to be safe. And you're not using other crappy stuff. Like the front end is always much more insecure. So if the cookie is secure, it can only be accessed by the server and the client cannot read its value. And this only works if it is from the same site. So I'm just going to go ahead and save it. Essentially, this takes in a name and a value and any attributes you want to set to that cookie, and it returns a cookie string. So the cookie string will look like this. That's what a cookie string will look like. It has the key right here, and then it has the value. And then it can have different attributes listed afterwards. And if we go back to issue cookie tokens, which is the function that was called in authentication, the cookie string is returned. The cookie string is set right here under the set cookie header, and then the client reads the cookie string and sets the cookie. Cool? Does that all make sense? Cool, 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 cool. Yeah, and so that covers login and sign up, and also authorization, how to create tokens and then send them back. But how do we use those tokens in subsequent requests, right? So now let's look at this example. This is an example of a backend function that I just made, really the only one that is really pertinent right here, the session action. This can be anything. This can be a user likes a post. This can be a user accesses a certain post. This can be, a user changing their profile information, literally anything. So it's a Lambda function once again. You load the data from the event body, and right here I have this function that checks whether a user has access. It takes in the event, and it takes in the data that was submitted. And let's go ahead and see what that looks like and trace the function calls. So we have has access right here. And so let's go ahead and trace the function call. So what does has access do? It takes in an event and it takes in a data. So first we check to see whether the user ID that is being authorized for is included within the request, whether it's included within data. And then we check to see whether the cookie that was stored on the client is included in the event headers. This is crucial because the cookie is what's storing our tokens. And if the cookie's not there, then that means that this is a spoofed call. You should not be accepting this call, and you should just be saying, yeah, no, this person doesn't have access, right? If the cookie is there, then we're going to set the cookie string right here, and we're going to call this function authorize user with tokens. Let's go ahead and see what authorize user with tokens is. It's kind of a lot of code, but in essence, it decodes the access token. So first it decodes the access token, and then it determines whether the access token has valid scope. The access token has valid scope if the user ID in the access token matches the user ID that's right here. So as you can see, what this function is doing is it's taking in the cookie string with the tokens that were sent up by the client, and it's saying, hey, does this cookie string, do the tokens within this cookie have the same permissions to access this specific user ID's resources? Does that make sense? Did that statement make sense? Okay, more or less. Cool. So first it tries to decode the access token. If it's a valid scope and the access token is good, then it will return this dictionary of like true and tokens and all this stuff. If it's not, then it tries to decode the refresh token. It sees whether the refresh token is valid or not. If the refresh token is valid, then it issues a new access token and it returns everything. And if it's not valid at all, if all the tokens are expired, it says that. You can look through this code. I'm not going to run through every single line, but do you understand essentially what this function is doing?
Yeah, kind of, yeah.
Okay, so I mean, it's decoding the access tokens. It's handling all the refresh access token stuff, and it's making sure that the access token is valid and that it's giving access to whatever specific user ID you put in right here. Cool, more or less. Cool.
Yeah, there's something to look into later.
Yeah, something to look into later. But yeah, it determines whether or not someone has access to it. And that's authorization. It's checking based on an authorization token whether or not the user has access to a specific resource. Does that make sense?
Yeah. So so say if I'm already logged in, right? Would I have to call that function or like see if I'm authorized every time I do I don't know, update my profile information, or
Yes.
even if I'm logged in, or?
Well, how does the server know whether you're logged in or not?
Okay. Yeah, I see.
Right? The server only knows you're logged in if you have a valid authorization token.
Mm-hmm.
Cool. Does that make sense?
Okay. Yeah.
Awesome. Well, that's pretty much all of the backend that you need to understand. And for those of you, if you're watching this separately, we're using the serverless framework with Python. And we can sort of go through that later. I just want to use this as a time to talk about conceptually how these things work, show some code examples. But yes. So this is good if you're creating a serverless backend for a website. Something to know, and something that's really important, is that the only way that you can use a cookie that is restricted to the same site and is secure and is HTTP only, the server that is returning all this stuff has to be from the same domain that your website is hosted on. So if your website is google.com, then the server that is returning all this stuff has to be api.google.com. This can be a problem if you're using Lambda functions. And so what you need to do is you need to look at this guide right here, and you need to look at how to set up a custom domain name using Lambda and API Gateway. But yeah, you just need to have the same server name. You need to have the same domain name for your server as you do for your website that's hosting. That's pretty much it. And then we can go ahead and look at a front-end example of what it would look like to call this backend function. So if you're creating a React app, which you probably are, unless people are watching this way in the future and there's some sort of other default, you're going to be using the fetch function, which is JavaScript ES6. So as you can see, I am requesting this one resource in the API. I have the post function here. I'm saying, hey, I want to include credentials, which means that the cookie that you have on your computer is going to be sent up. That's all that that means. If you have credentials include, it sends up the cookie. And then here I have the body, which is exactly what we were talking about right here. Right? We're loading the body right here. So we want to have the username and the password. That's pretty much all that we're posting here. And obviously it's going to depend based on what function you're sending up and what data you're sending up. And then after we have the call, we want to make sure that there was like a success or a failure, and then we can handle that success or the failure right here. That's pretty much it. Does that make sense? Are there any questions that you have, Braden or Yash, over any of this? Obviously, it's going to be a lot harder once you implement all this code, but conceptually, does everything make sense on how authentication and authorization work with like a client-server model?
Yeah.
Yeah?
Yeah.
Okay.
Obviously, we'll be looking at this more in a much more deeper scope, but for now, yeah, this is pretty helpful.
Cool. And I was going to try to make a tutorial where I deploy all this code and stuff, but I'm not going to do that. I'll do it later if you guys really need it. And if I decide to make a Medium video out of this, or a Medium article, and help a lot of people and make one of those code walkthroughs. But for now, I will put this into the Notion, and I will link the Notion to the YouTube video so you guys can see this, and it should give you a good understanding of how all of this works. And if you need anything, obviously just text me, or actually first read the resources that I have there. But yeah, pretty much it. Oh, cool. Did someone say something in the chat? Oh, we'll be back in a minute. I'll stop recording.